Okay. So let's get started with revision of graphs. And of course, we're going to just start off with some simple ordered pairs, which means we're just going to use the formula we've been given to fill in the table. And once again, we have our x input values and our y output values. So let's get started off with the 16 first. Do I substitute that into my x or my y? Will I be substituting that 16 into x or into y? Let's hear what we have to say. Just based off where it is on the table, is that an x value or y? Thank you, Alice. It's a y value, okay? So then 16 will be equal to negative 4x plus 8. I want to get rid of everyone that's around my x. What do I start with first? Who do I get rid of first on the right-hand side? Negative 8. Great. So it goes over to the other side and it becomes 16 minus 8 is negative 4x. What's 60 minus 8? 16 minus 8, that would be 8 is negative 4x. Divide by negative 4 on both sides. Can I have a value 4x, please? Is equal to negative 2. Lovely. Off to a fast start. And our negative 1 is at the top of my table, which means it goes on the x or y value. Negative 1, if it's at the top of a table, that means it goes on your x value. There we go. So y is equal to negative 4 times negative 1 plus 8. What's negative 4 times negative 1? Alice is on fire today. That will be a positive 4 plus 8, which is equal to 12, and that is my value. So that's basically all we are doing here. If you find the values for the next 3 ones, just tell me in the chat. Fastest fingers first. Okay, so I'm going to work them out, but once you have an answer, just post it in the chat. We're going to substitute 8 and then a 2 and then a 12. Okay, so I'm going to go ahead and go with 8. Okay, so 8 is equal to negative 4x. Okay, Alice says it's a 0. 8 minus 8, negative 4x, and it is indeed 0, because from here on, we're going to divide both sides by negative 4. Therefore, x is 0 for the next one. Great. Let's move on to 2. Negative 2. Yeah, I got confused for a second there. Negative 4 times 2 plus 8. This is a negative 8 plus 8, which is 0. Guys, you're not even giving Alice a run for her money. Not even giving Alice a run for her money. And the last one, 12 is negative 4x plus 8. Over to the other side. Negative 4x. It is a pretty small cluster. It's tiny, isn't it? People are resting. People are resting. Minus 4, and Alice was correct with all of them. Negative 1. Wonderful. Wonderful, wonderful. Okay, here's my second set of ordered pairs. Let's hear. Okay, once again, we have our x and y values. Fastest fingers first. Let's see who's going to get to my answers first one. Y is equal to negative 2 minus 2 squared. What's negative 2 minus 2? Be careful. What's negative 2 minus 2? That would be negative 4 squared. And a negative 4 squared, negative 4 times negative 4. That is not negative 16. It is a positive 16. Because remember, you're squaring the negative as well. Okay. So it's a negative times a negative, which is going to end up giving you a positive answer. So my first one is 16. Okay, let's see. Now we're going to substitute our 9 into my y value. How am I going to get rid of that square? How am I going to get rid of that square? What is the inverse operation for squaring? We went quiet. What's our inverse operation for squaring, guys? I want to get rid of this guy. It's a square root, but, if you've been around for a long time, you know what I'm going to say. But if we introduce a square root, what did we say we have to do again? Plus minus. Beautiful, Alice. Beautiful. Okay, so for those of you who were not sure when I said this, if you are introducing a square root in a question, you have to say positive or negative because there are two possible solutions for a square root. I'll show you what I mean just now. So what's the square root of 9 again? Square root of 9. Hey, boo. What's the square root of 9, guys? Equals x minus 2. 3. Thank you. So what this plus minus means is either 3 is equal to x minus 2 or negative 3 is equal to x minus 2. That means we're going to have two solutions. If I take this negative 2 over, what happens? Let's start with the first one. It's going to be a positive 2. Do you guys agree? So there's going to be a 3 plus 2 is equal to x. So my first solution is x is equal to what? My first solution is x is equal to 3 plus 2, which is 5. My second solution will be negative 3 plus 2 equals x. How much is negative 3 plus 2? That is negative 1. Okay, now based on where we are on the table, is my solution 5 or negative 1? Look at where we are in the table. Are we going to take the negative 1 solution or the 5 solution? We're going to take the negative 1 solution. Thank you very much. Okay, now for those who don't understand what this plus minus is, okay, if I say to you x squared is equal to 16, right? It is true that 4 squared is equal to 16, but do you agree that negative 4 squared is also equal to 16? Because it's a negative times a negative. So you always have to state that there are two possible solutions. So it's either a positive 4 or a negative 4 that's equal to 16. And if you look at this graph, the way it's drawn, what does this graph look like? What does this graph look like? A quadratic graph. Is it a straight line? Does it curve once? Does it curve twice? What does it look like? The one with the square at the top. It curves once. Remember, straight line graphs has no exponent in the x, okay? This graph looks something like that. And the reason it will have two solutions is, if you look at here, if I say x is equal to 1, y is equal to 1, for instance, do you see that y is equal to 1 in two places? Either over there or over there. That's why there are two possible solutions for a square root. Can I have a thumbs up, thumbs down on that? So my graph curves, which means this condition, my English just went south. This condition will be true on two separate occasions. So y is equal to 1 on positive 5, but it's also equal to 1 on negative side. Okay. So that's why there are two possible solutions. But if you just look at where we are in the table, it's clear that my solution is negative 1 because we went negative 2, negative 1, 0, and we're increasing and so on. Okay, let's look at the next one. Now we're substituting x is equal to 0. So y is equal to 0 minus 2 squared. What's negative 2 squared? Negative 2 squared. That would be a positive 4. Okay, let's look at the next one. This time my y is equal to 0 is equal to x minus 2. What's the square root of 0, guys? It is 0. This time I didn't add a plus minus. Why not? Why did I not add a plus minus here? Does it matter? Thank you. It doesn't even matter. Okay, 0 can't be positive or negative. It's just 0. So we don't have to put a plus minus over here. But then my solution is, therefore, x is equal to what? Positive 2. Nice. Then I want you to look at what happens with the last one. Okay. Y is equal to 4 minus 2 squared. And 4 minus 2 is equal to 2 squared. And how much is 2 squared? 4. Do you see my point? There are two different places where y is equal to 4. Okay. So when x is 0 and when x is 4, y will equal 4. That means your graph goes down on the side where it's 0 and up on the side where it's 4. Okay, another thing about this graph, you will always have a positive y solution. And why is that? Why do I say that with so much confidence? No matter what you choose as x, your y will always be positive. How do I know that? I know that because we're squaring, and as soon as you square a number, thank you, Alice. As soon as you square a number, it's positive. Okay. Wonderful. Okay, let's get going. I have a lot of questions for you guys because I know you guys know this. Now they say the equation y is equal to a half x minus 2 is given. If the output values are negative 3, 5, and 7, determine the input values. Output values means what? Where are we going to substitute negative 3, a 5, and a 7? If they say these are my output values, where do I substitute them in my formula? To the x or to the y? So I'm either going to substitute it there or there. Think carefully. Is x my input or output value? There we go. We're going to substitute it at y. So all of these numbers are going to go in where my y is, because that's the output. X is what we insert into the formula, and y is what we get out. Okay, so then the first one, we'll say negative 3 is equal to a half of x minus 2. Who do we get rid of first here? I want x to be alone on its own. So who am I going to get rid of first? The 2. So I take it over and it's going to become a positive 2. So negative 3 plus 2 is equal to a half of x. What's negative 3 plus 2? Negative 3 plus 2, negative 1 is equal to a half of x. How do I get rid of a half? Timesing by half is the same as dividing by 2. Nice, Alice. So I'm going to multiply by 2 on both sides. Times 2. This will cancel each other out. Okay, so then I'm left with, therefore, x is equal to how much? Negative 2. Do we all understand that? Can I have a thumbs up, thumbs down on the timesing by 2 part? I know it might be a little bit confusing, but do we all understand that? Just a little bit of a check-in. Okay, I see a few thumbs up. Everyone else? I don't know where we are. Come back to the lesson. Okay, next one. 5 is equal to a half of x minus 2. Same procedure, inverse operation. 5 plus 2 is a half of x. You can also solve this using inspection. Do you guys remember how to solve things using inspection? So you say a half of a certain number is equal to 7. So what is that certain number? You don't even have to go through all of this, but a half of a certain number is equal to 7. What does that certain number have to be? That's how you solve by inspection. A half of a certain number is equal to 7. Nice, Alice. That means the certain number has to equal 14. Now, I know some of you are going to say, but my teacher wants to see working out, and that's okay. Okay? If your teacher insists on seeing working out, then you do it like this. But if your teacher's okay with solving by inspection, then you can just do this. Because it's an equation, right? And then the last one is 7 is equal to half of x minus 2. Again, my 2 goes that side. 7 plus 2 is a half of x. Tell me how much x is, guys. 9 is equal to a half of x. I'm going to go back and multiply by 2 on both sides. Nope, be careful. We are multiplying by 2, remember, to cancel these guys out. Therefore, x is 18. Then you write them out like they have written the output values for you. So you'll say that means our input values, x is an element of negative 2, 14, and 18. All right. Makes sense? Hopefully it does. Okay, I'm not going to do the same thing again. Now, we remember that we spoke about multiple representations of graphs, right? So we said you can either have it in words where you describe the relationship, where you say x is twice of y less 15, okay? Or formulas, which is what we've been using, y is equal to 2x plus 5, or the spider or flow diagram, or an actual graph, which is what we have here. So now they say we have given you a graph. Find the formula. Where are we going to start with this guy? I need to find the formula. Where would you start with this if you had this in a test? Okay, you can make a table. Yes, that's fine. You can make a table. What's the point of making a table? We're looking for the actual coordinates, right? How many are there? 1, 2, 3, 4. Okay, pretend this is straight, okay? Pretend this is straight. Great. So let's look for the coordinates of the first point, which is the yellow one that I've highlighted over there. Tell me my x value and my y value for the first one. Just to make things easier, please write them as coordinates, as in the x value and the y value. Then I'll fill it in on the table. So first point, which is the yellow one. Let's see, 1, 3. That is correct, but I said write them correctly. You are all cheating me. Where are my brackets? You guys are not writing my coordinates properly. Thank you. 1 and 3. Great. Coordinate number 2, which is the blue one. Let's hear. There we go. 2 and 4. Coordinate number 3, which is that one over there. Peach one. That would be 3 and 5. And my final coordinate, which is the green one, is, let's see, 4 and 6. Great. Now we have a table. Does anybody remember what the general formula for a straight line graph is? We're going to have to find the formula, which means we have to start with the general formula. Does anybody remember what it is? Nice. Mx plus, I'm guessing the last x is a mistake. There we go. Y is equal to mx plus c. What does this m stand for? What is that m? That would be your gradient. Thank you, Arian. And the C is your Y. What? It's not just the Y, it's a Y something. Not axis. You're close though. Very close. What's the special word for C? Your y-intercept. Nice, Marlene. Great. How do we find the gradient? Does anybody remember how we find the gradient? Yes, Musa, that would be correct. Intercept. Formula for my gradient. I'm going to write here m equals, and I'm going to wait for someone to tell us how we find the gradient. Anyone? I hope we're looking through our notes and notes. Nope, that would not be correct, Alice. There we go, Arian. Y2 minus y1. It was just the sign thing. Alice, you were very close. Over x2 minus x1. Okay, let's take the following 2 points. This one and this one over here. So what is my y2? It's been a good holiday. What do we say is y2? Remember, it doesn't matter which one you choose to be y2. So which one are we choosing? Okay, Alice wants to choose 5. It's fine. Alice is choosing her own points, doesn't want mine. So let's go with this one. y2 is 5 minus, which one are we choosing as y1? 4. Okay, 5 minus 4 over x2. X2 will then be what? 3 minus our x1 will then be 2. Great. Then we're left with 5 minus 4, which is 1 over 3 minus 2, which is another 1. That means my gradient is equal to 1. Great. Y is equal to... Do we have to write the 1, guys? Do we have to write the 1? No, we don't. Okay. Well, x plus c. How are we now going to find c? We have found my gradient, and now we need c. How do I find c? It's here. What do we have to say? Let y equals 0. That's no. Okay, I see what you're thinking of, Marlene. You cannot choose that because of, that's when you already have the formula. But if you look at Arian and Zenande, we have to substitute one of the coordinates. So let's use this guy over here. So where I have y, what am I going to substitute? I'm going to substitute, if I'm using the last coordinate, I'm using the final coordinates over here. So then in y, I substitute 6 is equal to, my x is 4 plus c. To get c on its own, I'm going to move 4 over to the other side, which is going to give me 6 minus 4. Therefore, c is equal to 2. So my formula will then be y is equal to x plus 2. Nice, guys. Thumbs up, thumbs down on that lovely one. Lovely. I love the participation, guys. I can't even feel that the class is smaller because you're all just... Okay, don't mind my pun. But you guys get it. Okay. Great. We have another one where we need a rule. Determine the rule of the following table and then calculate the value of A and B. Mm. 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 Great. Once again, y is equal to mx plus c. Okay, let's choose coordinates first. Okay, give me two coordinates that we're going to use to find the gradient. Give me two coordinates, any two coordinates. 2, 12. Where is it? Okay, we're going to use this guy. And another one. We need to choose first, otherwise everyone is doing their own thing. 3 is okay, so the ones next to each other. Also, how did I know that this is a straight line graph? You can only use this formula if you're 100% sure that this is a straight line graph. So how did I know? Did I just guess? There's a certain way that I figured out that this was a straight line graph. Does anybody know how I did that? From negative to positive, not quite. Not quite. My clue is look at the y values. What can you tell me about the y values? Look carefully. What can you guys tell me about the y values? There's a certain way that I can tell this is a straight line graph. A very specific way. Yes, it increases by 5. You look at the y values. If there is, what did we call that again? This thing where everybody's increasing by the same thing. There was a special word. It was your constant difference. So we know it's a straight line graph. Okay, so just remember to always check before you start using y is equal to mx plus c. Otherwise, it's not going to work if it's not a straight line graph. And then you're going to end up with a very confusing sum. Okay, so now we know it's a straight line graph. And we've chosen our two coordinates that we're going to use for the gradient. Those two guys. Great. Let's see. M is equal to y2 minus y1 over x2 minus x1. Which one is my y2? Which one is my y2? Anybody? $12. Thank you, Zanandi. 12 minus, which means my y1 has to be 17, divided by x2, then has to be which one? If y2 is 12, then x2 has to be the 2 minus the 3. Great. What's 12 minus 17? Not just 5, it is negative 5 over 2 minus 3, which is negative 1. And negative 5 divided by negative 1 is m is equal to 5. Great. So now we know it's y is equal to 5x plus c. Let's substitute a random coordinate, one that we haven't used yet. Let me see which one you guys were picking up there. Okay, Zananda said 1 and 7. Let's go with 1 and 7. So then 7 is equal to 5 times 1 plus c. Therefore, c is how much, guys? There we go. Therefore, c is equal to 2. So my formula is y is equal to 5x plus 2. Great. Now they say after that, look for A and B. Now, to find A, I have to substitute 14. Where's 14 going to be substituted? In the X or in the Y? In the X. Great. So Y is equal to 5 times 14 plus 2. How much is 5 times 14? 5 times 14, it's 70 indeed, plus 2. Therefore, okay, maybe I should have written A here, ne? Just to avoid confusion. A is equal to 72. Great. And as B, for B, are we going to substitute 102 in my X or my Y value? Y value. So 102 will be equal to 5 times the B plus 2. Take this guy over to that side. Then I have 5b is equal to 100. Divide by 5. Divide by 5. Therefore, b is equal to 20. And we're done. Can we get a thumbs up, thumbs down for this lovely question, please? Wonderful, guys. Wonderful, wonderful. Thank you. Okay. Now I have something a little bit more interesting, and then it's going to be the brain break. Okay. So given the formulae, so we have two formulae here. S is equal to Vt, and V is equal to a half of G times T. Calculate the positive value of T. What does that tell you? What does that mean? You already know you're going to have two possible values, so they want the positive one. Okay. If it is given that S is equal to 32 and G is equal to 4. Oh, isn't that interesting? So we're looking for T, and T is present in both formulae. So let's see how we're going to do this. If you got this in a test paper, where would you start? Where would you start if you got given this in a test? It's here. Substitute, wonderful. So I'm going to substitute S and G. I have two formulas, but I'm going to substitute S and G. Okay. Now, simultaneous, Alice, is very tricky because you don't have the same variables here. Do you see that? But it is going to end up being simultaneous after we substitute. Let's see. So I'm going to substitute S. So 32 is equal to Vt, and that'll be my first equation. Okay, and another thing they gave us is G, which we have in my second formula. V is equal to a half of 4 times T. Can we simplify this a little bit? My second formula that I've written there, can we simplify it? Geez, I need to cough and it's going to sound terrible, so I'm going to mute myself. Whew. Okay, let's simplify it. How do we simplify it? How do we simplify it? 4 divided by 2, great. So then V is equal to what? Yes, 2T. Great, so I've substituted. Now what? I have now substituted, so what's the way forward? Okay, which means what, Alice? Tell me what I'm substituting where, because simultaneous means we're substituting something somewhere, right? Are you with me? V equals 2t, okay? Yes. So I'm going to take the V that I have over here and substitute it into equation 1. So I'm going to say substitute 2 into 1. Great. So then 32 will be equal to not VT, but 2t times t. Okay, great. Now what's happening on the right-hand side of this equation? What can we do here? What can we do on the right-hand side? Multiply. So what's 2t times t? Be careful, Marlene. It is 2t squared. Okay, 2t squared. Great, we're much closer to where we need to be. I need to get t on its own. So what do I do next? If I need to get t on its own, divide both sides by 2. That's going to give me t squared is equal to, what's 32 divided by 2? 16. Great. Now what do I do? Square root, and we both know that we don't need to do the minus. Okay, well, we actually do, okay? We actually do. I'll show you how we expect you guys to write it. So you're going to say this is equal to plus minus the square root of 16. What is the square root of 16? 4, or t is negative 4. Then you say, but we want the positive solution. Therefore, t is just 4. Happy? Can we have a thumbs up, thumbs down? Lovely. Screenshotters, I'm going to give you a few seconds to do your thing before we move on to the brain break. Okay. Great. Now, let's see. We have to fill in these operations to make it true. But I'm going to give you a hint. And your hint is you need brackets somewhere. Whoop. Your hint is that you need brackets to make this true. If anyone thinks they have figured it out, you can unmute yourself. Now you can unmute yourself, and then we can hear what you have come up with. Okay, so you're going to need to tell me first where to put the operations and where to put brackets. Anyone figure this out yet? Let's hear. Anyone have an idea? I'm going to give you guys 1 more minute, then I'm giving you another hint. Anyone? Would you guys like another hint? No? Okay, so must I give you where the brackets go, or must I give you one of the operations? Which hint would you guys like? Either where the brackets go or one of them. Okay, let me give you the brackets. There and there. Oop, there. I'm sure now you guys will be able to figure it out. Easy, easy. Anyone have it yet? No? 2 plus 1 times 6 times 6. Okay, let's try it. Okay, 2 plus 1 is equal to 3 times 6 is 18. 18 times 6 is definitely more than 48. So that's too high. Let's try again. Remember BODMAS. Okay, Bali has sent her attempt. Anyone else? Are we having another hint? Must I give you another hint? Another hint? Okay, there's one of the operations. Here's your second hint. I'm giving you guys 1 more minute, then I'm giving you the answer. 1 more minute, then we're giving the answer. So we have a 2 times 1. Okay, Alice says it's 2 times 1 plus 6 times 6. Okay, let's see. 2 times 1 is 2. And if you add 6, this will give you 8 times 6. Yay! Well done, Alice. Boo, 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 boo. There we go. And Arian. And Marlene. And I have one last one. Okay, for this one of these shapes are wrong. Okay, and I need you guys to tell me which one. So this is number 1, number 2, number 3, number 4, number 5, and number 6. Which of these shapes are incorrect? Let's see. Which of these ones are incorrect? Ella's like, boo, 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 boo. Okay, Marlene says number 3 is incorrect. Okay. Does anyone have another option? I'm going to circle the one that Marlene says is incorrect. If you also agree it's number 3, just send number 3 again. I just want to see what everyone thinks. Oh, Marlene has changed. Okay, Marlene has changed. Okay, Marlene says 6, and so does Alice, and so does Sinubuhle. Why do you guys say 6 is incorrect? Red circle! That's correct, guys. If you look here, all the circles are yellow. Look, yellow, yellow, yellow. All the squares are red. Red, 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 red. All the hexagons are blue. Blue, blue, blue. This one is the only one with a red circle, which means it's incorrect. Nice, beautiful, guys. Great work. Great work. Now let's do 1 or 2 of these and then we can call it a day. So for each of the following, firstly find the gradient, state whether the gradient is positive or negative, write down the equation, and state if it's increasing or decreasing. And I want us to start off with D. Okay, now before we even figure out the gradient, I want you guys to tell me if the gradient is positive or negative before you even work it out. How do you know that, Marlene? So Maureen says this is a positive gradient. How do we know that? You're correct, but we need to know how we identify that. It's an increasing graph. So you've answered B and D already. It's an increasing graph. Great. Let's find the gradient. A. M is equal to y2 minus y1 over x2 minus x1. Great. What's our y2 for graph D? Our y2, you guys can choose either one of those. Our y2, we don't have a -3 on graph D. We're over here. Okay, so Nandi wants 9 to be y2, okay? Minus our y1, 6, divided by x2 will then have to be what? 3 minus x1, which will have to be a 2. Great. So in my numerator, I have 9 minus 6, which is 9 minus 6, which will then be 3 over 3 minus 2, which is 1. That means your gradient is equal to 3. And then your formula is then y is equal to 3x. How do I know there's no c? How do I know for sure that there's no c? I'm not even going to try and work it out. Does anybody know? How do we know for sure that there's no c? In the meantime, while I figure that out, can you guys do G, please? I know there's no C because the graph goes through the origin. So if you have a straight line graph that passes Y at 0, that means there will not be a C. Yes, Alice, it doesn't intersect the Y axis. Okay, so the equation is just y is equal to 3x. There won't be a c value. All right, let's do G. Okay, firstly, is the gradient going to be positive or negative? Will the gradient be positive or negative? For G, it'll be negative. And why is that? Because it's a decreasing graph. Great. Let's look for the gradient. M is equal to y2 minus y1 over x2 minus x1. What are we choosing to be our y2 in this case? 10. Okay, 10 minus, what is my y1? Minus 6 over, that means my x1 has to be x2, excuse me, my x2 has to be -5 minus my x1, which has to be -3. Just to clarify, remember, the first negative is because it's in the formula. The second negative is because of the coordinate itself. And what is that negative going to cause? It's going to cause this whole symbol to become a positive. So I'm going to have -5 plus 3. Great. So then 10 minus 6 at the top in the numerator. We have 4 over -5 plus 3, which is a -2. Therefore, my m is equal to -2. And that means the formula for this graph is equal to y is equal to -2x. I think we can do one more. We have time for one more. Let us do H. Let's just do H. Okay. Let me write here graph H. Okay. Negative or positive gradient? Nice. Sinoguhle was already there. Negative and decreasing. Let's find the gradient. Gradient is what? Number A. M is y2 minus y1 over x2 minus x1. What is my y2 for this one? 9 minus y1, 6 over x2, x2, negative 3 minus x1, negative 2. Great. So 9 minus 6 over negative 3 plus 2. 9 minus 6, that is 3 over negative 3 plus 2. Negative 1. And 3 divided by negative 1 is equal to negative 3. That means my graph is y is equal to negative 3x. Excuse me.